Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 183 of our POTD series and today's this question name is count even length and this is a medium level question and you can see here the accuracy is very low. It is around 15%. So that is because this question is easy but this is a little tricky question for Java and CPP programmers and that is because they have a particular range for integer and we have to return here an integer, but in Python there is no limit for integer values, so that is why it is a little tricky for Java and C developers and programmers. So we will just see how can we solve it. This is a very easy question. So first of all we are given a number n and we have to find count of all binary sequences of length 2n. So first of all we are given a n and we have to make a binary sequence of length 2n. Binary means 0 1 values, right? Such that the sum of first n bits is the same as sum of last n bits. So that is our condition that we have to satisfy, and the answer can be very large. So we have to make first of all the sequences which have sum of first n bits equal to sum of last n bits, and after that so we have to also return modulo 10 to the power 9 plus 7. So that is the standard, and so this is n equal to 2. So when our n value is equal to 2, so n equal to 2, let me zoom it first. N equal to 2, so that means just a second. So that means we are given here 2n. So 2n is our space. So 1, 2, 3, 4. So there are 4 bits that we have to consider, and consider here is a wall just for a reference, and we have to consider here 2n length and such that the sum of first n bits is equal to sum of last n bits, so that sum of these 2 bits equal to sum of these n bits. So we have to consider that cases. So when there are so first of all what are the cases? So first of all first number is 0 0 0 0. So sum of these 2 bits, sum of these numbers, so is equal to sum of these number. Is that true? Yes, you can see the sum is 0 here and sum is 0 here, so they are equal, so we can consider this is our valid case. So this is our valid case, and after that what is our next valid case? When the sum is 1 and sum here the sum is also 1. So what are the cases which have sum equal to 1? So here when we consider 1 0, and here we can also consider 0 1, and we can also consider here the same case is 1 0 and 0 1, and we can also make some cases like this. So when we have a combination of this, so like when we have a number 1 0 1 0, so there we have sum equal to 1 here and sum equal to 1 here, and after that what is the next case? When we make combination of this 1 0 with 0 1, so 1 0 0 1, so this is also a valid case where first n numbers have sum equal to 1 and last n numbers also have sum equal to 1, so this is also a valid case. And after that we can consider this case with this and this case with the upper one. So there are total of 2, so here you can see 2 cases are here and 2 cases are here, so 2 into 2, total of 4 possibilities from this. So how can we say that there are four possibilities? So if you are a beginner and you are just starting to practice, you may be thinking that we have to find all the combination and we have to linearly iterate and make all these combination, but that is not the case. We have to calculate the answer. We have to calculate the count. So we not need to necessarily make these subsequences or sequences. So we just have to find the answer. We have to just find the count. So what we can do, we can just find this count, that this count is 2 and this count is 2, and we can just multiply them with each other, so that final answer will be 4 if we have only 1 bits, and we have also 2 bits because there are 2 positions. So there can be also 2 bits, 1 1 here and 1 1 here, so there is only one possibility for that. So one answer from here, and you can see 4 answer from here, and there is also this one possibility. So 1 plus this one plus this 4 plus this one, so total answer will be 6, and you can see here it is. So we have to just calculate the count. So first of all this case, then this case when we have sum equal to 1, and then when you have sum equal to 2. So first of all sum was 0, then 1, then 2. So you can see here we are iterating from 0 to what is this, n. So that is our first condition. We have to iterate from 0 to n. So let me just write it here. Iterate from 0 to n, and that is the thing now you know. And after that how can we count? So we know that this is our case when we have 2 bits, when 2 is equal to n. So that is the simple case. We can just make one possibility. But what about this? So let me just clear it now. How can we calculate this? So we have first of all 2n length. So n equal to 2, and we have 2n length 1 2 3 4. So when we have to count the number of ways with sum equal to 1, right? So we have to find number of ways with sum equal to 1. So we have these places. So how many places we have? We have two places to place our one value, okay? And we can place either our one here or we can place our one here, and the rest of the places will be 0. So suppose we have, yeah, here we have two places, right? And we have to place how many number of ones? We have to place only one here. So there are a total of two places and we have to place only one here, 2C1. So that is the formula. So I think you know about this already. So this is our combinatorial, and the formula to calculate this one is, so this is NCR. So there is a general formula to calculate this combination, that is n factorial by r factorial into n minus r factorial. So I hope you know this thing, what is this factorial and what is this NCR. So let me just give you some another example if you don't understand this thing. So suppose we have three places, 1, 2, 3 or 4. So suppose we have four places to place our values, and suppose we have to place only one here. So how many places we have, we can place this one. So our one can be here, so we can place our one here. So this is one possibility, or we can just remove it from here. So here it is 0 and we can place our one here. So there is our second possibility, plus 1, or we can just remove our one from here and place it here. So okay, we have to remove it from here. So this is our third possibility. This is our number that is unique, and that is our third sequence. So we can just remove it from here and place it here. So that is our fourth possibility. So there are total of 4 sequences we can make when we have, you can see, when we have 4 empty spaces. So here we have 0. When we have 4 of total empty spaces, so n equal to 4, and how many number of 1 that we have to place here. So how many number of 1 we have is 1. So 4C1. So 4C1, let me just calculate it. NCR, that is here 4C1. So it is 4 factorial by 4 minus 1 factorial, that is 3 factorial, into r factorial, that is here 1 factorial. So 1 factorial is 1, so we will not consider it here. And 4 factorial is equal to 4 into 3 factorial. So 3 factorial will cancel out 3 factorial and the final answer will be 4. And that is the cases you can see here. First I will place one here, then here, then here. So there are total of 4 combinations. But if we have here 2, number of ones equal to 2. So when we have number of 1 equal to 2, then our cases will increase or decrease. So first we can place our first one here, second one here, and rest will be 0. So this is our one possibility, and we can just change our possibility here. So here will be 0, here will be 1, and after that here will be 0, and here it will be 1. So that is our third possibility. So we can just directly use this formula to calculate our number of possibility when we have n number of spaces to put our two ones. So 4C2, that is 4 factorial by 4 minus 2, that is 2 factorial, and then 2 factorial. So it is 4 into 3 into 2 into 2 factorial will cancel out 2 factorial, and then we have divided by 2. So 2 factorial is also 2. So this is our answer. 4 into 3 is 12 divided by 2. That is our answer will be 6. So that is how we will calculate our formula to find out this. Thing. So I hope now you are getting this point. So first of all, we have to iterate from 0 to n, and so let me just make it some big example. Okay, so suppose for our example we have n equal to 5, or we can say n equal to 4. So there are 4 places here and there are 4 places here. So there are 4 places to place our 1 from 0 to 4. So we have to make all the cases. First of all, our sum will be here 0. That means there is some 0 and there will be also some 0. So we have to find all the cases which have sum equal to 0. And then we have to place sum equal to 1. So we can just place our 1 here, here or here. So there are 4 possibility for that. And then we will place our sum equal to 2, then 3 and then 4. So we have to count all the possible cases. So what are the total number of cases when our r equal to 0? So we have total number of places equal to 4. So here we have 4 places to count to place our 0 number of ones, and here we also have 4 number of places to 4 number of total places to place our 0 number of ones. So here it will be 4C0 and it will be also 4C0, and we know from this thing that we have to multiply them with each other. So there are total of 2 possibility to place our number of ones, and there are also two total possibility to place our ones. So we can just multiply them with each other. So 2 into 2, that will be 4, which was our answer. So we have to multiply both the possibilities. So we will just find this 4C0 and multiply it with this 4C0. Okay. And after that, we have another 4 more places here and 4 more places here. So now we have to place our one number of bit. So either we can place it here or here or here or here, or the same thing for this side. So here total number of places are 4, and we have to place one number of one number of bit. Okay, and here are same 4 number of total places, and we have to place one number of bit, and the total combination that we can make is 4C1 into 4C1, and that can be 0001. So this is 10001, and 0010, 0010, okay, 0100 and 100. So we can just this is our first combination of 2n number, 2n length number, and this is our second combination of a 2n length number. This is third, this is fourth, and fifth, sixth, seventh, eighth, and you can just multiply them with each other. So you have to don't have to do it manually. So four possibility are here and four possibility are here. So 4 into 4 is total 16 possibilities. So I hope now you got this thing. So how we are finding any possibility for any particular bit, right? So first of all, we have to iterate from 0 to n, and what we have to do? So we have to find NCR. So here we are finding 4C1, and here we have to find 4C2, 4C3, and after that 4C4. So what is the total count? We have to add all the values, right? So we have to finally add all the values. So what will be our final answer? So first of all, we are finding 4C0, right? So what is our final answer? So first of all, we are counting 4C0 into 4C0, and then we are adding 4C1 into 4C1, and after that we are adding more values, that is 4C2, and this 4 is our n, so let me write it more generic. So it is NC0, NC0, and this is NC1, NC1, and here it is NC2 into NC2. So it will go up to NCN into NCN. So that will be our final term, and we have to add all the values, right? So that will be our final answer that we have to return. So we can make some general formula so that we don't have to count this combination again and again. So that will be more repetitive case. So what is the formula for our NC0? That is n factorial by r. So r is here 0. So 0 factorial into n minus r factorial. So what is n minus r factorial? That is n minus 0 factorial. So n minus 0 factorial will be n factorial itself. So it is the thing, and the same thing will be here. So this is the exact same thing here. And after that we have to add second value. So what will be the second value? So second value will be n factorial divided by r factorial, that is here 1 factorial into, so into n minus r, that is n minus 1 factorial. So you can see what is the difference. The upper, that is numerator, is same here and numerator is same here, and in denominator there are two terms and here are also two terms, and we have to just find the difference. So here it is first 0 factorial and it is changing to 1 factorial. So how it is changing? And you can see that is here denominator. So if it is NC0, then it is 0 factorial. If it is NC1, then it is 1 factorial. So we just don't have to find again 1 factorial, or if it is a very large term, then we can just use the previous term. Okay. So if it is 0 factorial, then we will just multiply it with our r. So 0 factorial into r, that is 0 factorial into our 1. So it will be 1 factorial, or suppose it is n minus 1 factorial. So if suppose it is very large term, or let's say it is x. So if it is here x minus 1th term, so if it in the previous term is x minus 1 factorial, and we have to find the next term, so we will just multiply it with x. So x into x minus 1 factorial, so it will be x factorial for our x term. All right. So that is how we are gonna find this term. And what about our second term? So our second term is first n factorial. So our second term is n factorial. So this is our second term and this is our first term in denominator, because the numerator is same. So we don't have to change it every time. So first this was n factorial here and we are changing it to n minus 1 factorial. So we are reducing 1 by n. So we are decreasing by n, or we can say we are decreasing by this term. So first we are decreasing n, then we will decrease n minus 1. So it will be here n minus 2 factorial. All right. And after that this will be n minus 3 factorial. So what we are dividing every time? First of all, we are dividing this term by n factorial. Then we will divide this term by n minus 1 factorial. Then we will divide this term by n minus 2 factorial. Right. So that is here. I hope you guessed this thing. So this is here n minus r factorial. So here this is, you can see n is here and r is here. So we are dividing it with n minus r. Okay, so that is how we are going to change our denominators. And let me just write the code for it. So first of all, we have to make answer here. That will start from 0. So first of all, we have to find out this term. So that is nc0 into nc0. So what is nc0? So every time we have to, we don't have to change our, we don't have to calculate our nc0 or ncr any value. So we will just get this n factorial and we will just iterate it one time. So it will be time complexity O of n. So we will just get this n factorial. So we will just store it n factorial, and that will be initially 1, and we will just iterate from 1 to n to find this n factorial. All right. So n factorial will be equal to, so n factorial into 1, that is first it will multiply by 1, then 2, then 3 up to n. So it will be n factorial like this, and we also have to calculate this term. So first of all, we have to start from here. So this is our first term, that is r factorial. So what is r factorial? R factorial, and you can see initially it is 0 factorial, and 0 factorial means 1. And the second term, that is here. So the formula was n factorial by r factorial into n minus r factorial. So it is here n minus r factorial, which is equal to, start initially it is equal to our n factorial. So n, it is n minus r factorial, and initially it is equal to our n factorial. All right. So what we have to do, we have to just change our denominators every time, and the rest of the things will be same. So what we are gonna do? So first of all, n factorial, and we have to divide them with these two values. So what we are gonna add in our answer, we will just create a new value that will be equal to n factorial. So n factorial multiply, sorry, we have to divide it with something, and we have to divide it with n r factorial into n minus r factorial. So r factorial into n minus r factorial. So I hope now you got this, how we are calculating NCR. So it is n factorial divided by r factorial into n minus r factorial, and we have to add this value to our answer. So answer plus equal to our value. And after that we have to change our numerator and denominator. So this is our numerator, sorry, we have to change both our denominator values. So this is our first value, and we have to change it to 1 factorial. So what is the value of our I, or we can say it r here. So I will just write it here r, because we are using here r, right? So first of all, r value is equal to 0, right? So we have to multiply it with 1 to get our next value. Okay, so we will just add here r plus 1. So from 0 factorial to 1 factorial, and let me just make it clear here. So it is 0 factorial and r equal to 0 here, right? And we have to convert it into 1 factorial. So what we will do, we will just multiply this term with r plus 1. So 0 factorial multiply this r equal to 0. So 0 plus 1. So it will be 0 factorial into 1. So it will be called as 1 factorial, and the value will be same. So we have to just do, this is our r factorial. All right. So r factorial multiply equal to r plus 1. So I hope now you got this, what we are doing here. This is our r factorial, and we are just multiplying r plus 1 to get our next term. And what about our second term? So what we are doing? So this term is n factorial and we have to convert it into n minus 1 factorial. So we have to divide it with our current value, that is n minus r. So we have to divide it with n minus r. So we will just do that thing. N minus r factorial will be equal to, we have to divide that thing. So n minus r factorial, n minus r factorial, we will just divide that thing with our n minus r. So we will first we will divide that with n minus 0. So r is here 0. So we will just divide that with n minus 0. So n factorial by that thing factorial. Okay, I think I'm writing the right thing. Okay, so we will just get this thing and no, that is not factorial here. Okay, my mistake. We are just dividing it with n minus 0. So n minus 0 will be equal to n. So n factorial divided by n, what it will be? So n factorial divided by n will be n minus 1 factorial. And after that, r equal to 1. So we will divide it with n minus 1. So it will be equal to n minus 2. So we are doing the right thing here. And at last, we have to return our answer. So that is all about our algorithm. And let us just okay, we are getting an error, and that is because we are dividing here something and that can be 0. Okay, so okay, I think here it can be 0. Okay, so we have to check here that r should be not equal to n. When n is not equal to r, only then we have to divide it. Only, yeah, because we cannot just divide everything with 0. So here we are also getting an error. That is the same here in this line. So how can we solve this? Okay, let me just write here some small example. Okay, it is also giving a wrong error, wrong answer. So what is the problem? I think we are doing the right thing. Answer is 0 initially, and we are finding n factorial. And after that, r factorial is initially 0. That is here 0 factorial. And after that, n minus r factorial is initially n factorial. And we are going from 0 to n. Okay, so that is 0 to n. Value is n factorial divided by r factorial into n minus r factorial, and we are adding answer, and r factorial will be multiplied with r plus 1, so it will be converted to 1 factorial. Okay, that is it, and that thing is also okay. So I don't know why we are getting this, but let me just tell you that we are gonna get integer, I think integer bound, what can we say that? I think that is our out of bound exception for our integer values when we are checking for our large number. So how can we reduce it? We can just use our long. Okay, we have to also use our mode value. So I will just use here long value. I don't know why it is giving us wrong answer, but I will just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to just use here long value so that we don't overflow our integer. So everywhere I will just use here long. I will just copy it. And we have to at last return it after typecasting it. Okay, so what we have to do, first of all, when we are multiplying also, we have to check for our modulo property, right? So when we are multiplying, then we have to modulo that value. So mod, and I think we have to write that separately, denominator. So long denominator, and that will be r factorial mod into n minus r factorial mod, and that will be our denominator, so we can just use it here, denominator. And we know that when we are dividing, we are getting an error, and I don't know why we are getting this wrong answer. So I will just check from 0 to n and from 1 to n. I think we are missing something here. Okay, we will just check. Let me just write the thing here. So first of all, we are getting our denominator and we are using here modulo property with our multiplication, right? So we have to every time use here our modulo property because this is our integer and we don't want to get an out of bound error. We don't want our integer to overflow, right? So every time when we are using some operator here, we have to use our modulo property. And so here we are multiplying, so that's why we are here using our modulo property. That is for our multiplication. So we have, if we have to multiply two numbers a into b, and then we have to mod them. So this property can be used directly, cannot be used directly. So we have to use here a mod when we are talking about large numbers. So a mod. So here it is mod multiply b. So this is our second number mod, and after that we have to mod that whole thing. So mod. So that is the thing we are doing here. So first of all, mod of our first number multiply mod of our second number and then mod of this whole thing. So this is our modulo property for our multiplication, and we have a different modulo property for our division value. So we will just write it here first. We have to use also here. So we are adding values, so we have to also use it here. So that is same for our adding. Okay, so I think I got that thing. I got the error. We are just using here value, and we have to use here value square. So you can just see here the thing. We are finding NC0, but we have to also add our NC0 into NC0. So we have to add NC0 square. So here we have to multiply value because that is the obvious thing. I just missed it out. So what we have to add? So first of all, you can see we are just finding the total combination of one side, and we have to also find the total combination of second side. So this is NCR and this is NCR. So we have to multiply them so that we can find total combination possibility, right? So that is the thing we are missing. So we have to multiply these values, and then we have to add. So I think we are gonna get the right answer, but there will be some. Okay, denominator cannot find symbol. Okay, we just write demon here. Denominator. Okay, we are getting a right answer, and let me just do that thing so that we don't have any integer overflow. So first of all, we are getting a denominator, then we are just using our modulo property, and we also have to use it with divide. So I will just tell you how we can use it with divide. So that is the must thing that you have to remember, how to use modulo property when you are dividing two values. So first of all, when we are, yeah, here we are multiplying two values, so we have to again use that thing, and we also have to add it with our answer. So first of all, when we are multiplying them, so mod, and here mod of this single value, again here mod. So here we are first modding this value, then multiplying it with this mod, and mod of this whole thing, and then we have to mod this answer, and again mod this thing, and then bracket close. So when we are adding two values, so first of all mod of this value, then mod of whole this thing. All right. So I hope now you are getting this point, how we are using our modulo property. That is the thing I am telling. So this is the exact same thing when we have our plus operator. All right. So that is the exact same thing, and here we are multiplying, so we have to again do the same. So it is r factorial multiply. So here it is mod and again mod. So here we are multiplying and here we are dividing. So we have to use a divide property of our mod. So what is the divide property of mod? So let me just tell you here. So when we are dividing two values, so when we have a and when we have a divided by b, mod. So we cannot just do it like here. So what we were doing in our multiplying and adding. So we were doing, and there. So when we are talking about multiplying and adding values, multiplying and adding, so we can just use this modulo property like here. But when we are talking about minus, when we are subtracting some values or when we are dividing some values. So modulo property will change a lot. So when we are dividing, we cannot just do it like this: a mod m divided by b mod m, and then mod of this whole value. So we cannot just do it like this because this value will be eventually 0. Suppose for an example 4 by 12. So when we are modding it with 6, so 4 mod 6, 4 mod 6 divided by 12 mod 6. So 12 mod 6, what is the value? This is 0. So 12 mod 6 is 0, and we cannot just divide something with 0. So this will give us some exception, and we cannot just do that. So what is the mod property for division? So that is here a multiply. So we know when we are talking about b, so we can when a by b, so we can just write it here as a into b to the power minus 1. So we will just write the same thing here, b to the power minus 1 mod mod, and we just have to find the mod of this value now. So here we can now use the modulo property of multiplication. So what we are going to do here, a mod mod multiply b to the power minus 1 mod, and then mod of this whole thing. All right, so we have to just find this thing now, and that is equal to power of b mod minus 2. So that is the thing you have to remember. So that means here if we are using here b to the power b to the power minus 1, and we are then modding it with mod value, some mod value, then this value is exactly equal to the result of this value will be definitely equal to b to the power mod minus 2, and that is the thing you have to remember. And if you want to know the reason, then I will just drop some documentation link, or you can just google it. So that is the thing we are going to use. We are going to do b to the power mod minus 2, and we are going to use it here. So here we will write power of b to the power mod minus 2. So that is the thing we are going to use here, and that will be our final answer for when we are dividing values. Okay, so when we are dividing, we can just write here, okay, a, so this is our n factorial mod mod. So n factorial mod mod, and then we have to multiply the second value, and then after that we have to mod the whole thing. So we have to multiply this second value, that is your denominator. We have to find the power, right? And after the mod of this whole thing. So this value is our b. So we have to find b to the power mod minus 2. So we will just write here some function to find the power. So power of this denominator mod minus 2. So we will just find the power of this denominator, that is denominator power mod minus 2, and we will just do the same thing here. So this is a and this is b. So a mod mod multiply power of this value with mod minus 2, and then mod of this whole thing. So I hope you got this thing what I am writing here, and I will just now create some function to find the power in our log and time. So this is our a value, this is our mod value. So how can we find power of some value in our log and time? So suppose this is our example, so 2 to the power 4. So we can just say it is equal to 2 to the power 2 into 2 to the power 2. So we will just find this with our formula, with our recursive function, right? So if it is a to the power b, so first of all, if we are writing some recursive function, then we have to also write base case. Okay, this is not mod b. So we have to find a to the power b, and we are just finding here n to the power mod minus 2. Okay. So if we have to find a to the power b, then what we have to do? So if we are finding a to the power b, then if b equal to 0, that is our base case, then we have to return 1. So if 2 to the power 0, then 2 to the power 0 equal to 1, that is the thing we already know. And then we have to find this. So if we have 2 to the power 4, then we will just find 2 to the power 2 and multiply it with 2 times. Okay. So long, that is half, equal to power of a b by 2, and we will just say full power equal to half into half. And we know when we are multiplying two values, then we have to use here modulo. So we will just make it global. So I will just use here this modulo property. So mod. So after that, what we have to do, we find the full value. But suppose this is our example, 2 to the power 5. So if we have 2 to the power 4, that means 2 to the power even. Then we can just divide it with 2 and we can just multiply to get 2 to the power 4. Because base same है तो power add हो जाएगी, right? But if we have power is equal to even, then what can we do? So 5 by 2 equal to 2, right? So it is 2 to the power 2 into 2 to the power 2. This is the value we are finding, and that will be 2 to the power 4. So it is 2 to the power 5 here, but we got our answer as 2 to the power 4. So what can we do now? So if our power is equal to an odd value, so if it is an odd value, then we will just multiply this answer with one more 2. That will be equal to 2 to the power 5. So if our answer, that is our power. So what is our power? That is your b. So if b mod 2 equal to 1, that means this is odd. So if it is odd, then what we will do? We will multiply this full multiply a, because that is the thing we are doing here. This is our full answer and we are multiplying it with a. That is our base. And if we are multiplying, then we have to use here mod. So I hope now you know this thing, why mod is here very important, because if we are not using mod anywhere, then you are gonna get integer out of bound, or you will just get some wrong answer that will be a negative value or something. So at last we have to return the full power value. So suppose I will not use here somewhere mod value, and you will just get wrong answer. Okay, I'm still getting wrong answer. More than expected. So what we are doing something wrong here. We are finding half. We are moving from 0 to n. Okay, I think we are missing something here. That should pass all the test cases. So let me just check again. So our answer is 0 and we are starting from 1. All right. And we are finding n factorial in of n time. So this is of n time. All right. And after that, this is our of n time, big of n time. And after that, we are moving from 0 to n. So we are just doing the same thing we are talking here. So we are just doing this thing from 0 to n. We are traversing here. First we are getting denominator. This is simple multiplication, and then we are getting full value, full current value. That is this NC0. So we can just write it as NCR. So NCR. I will just copy this, and after that n factorial into power of denominator into this. So I think this is taking a more time. I think this function is taking a lot time, right? But that should 10 to the power 5 here, and this is a 10 to the power 9. Okay, I think this function is taking time more than expected. But every time we are dividing, so it should be taking log n time, log 10 to the power 9. So it should be taking log 10 to the power 9 time. So I will write here of log 10 to the power 9. That is 9 log 10. And after that, we are just simply adding that value to our answer. And that is our simple of and time, right? But I don't know why we are getting this wrong answer here. TLE here. Okay. So I think we have to optimize it here. Okay, let me just check how we are gonna get our right answer, and we will be back here. Okay, so I found the problem. We were just doing some mistake here. We were not using that modulo, so that is why long is also going out of its range. So we have to also keep this long in the range. So that is why we also have to use here mode, and that's how this algorithm is gonna work. And it is a little bit more complex when we are using it in Java. If you are doing some algorithm in Python, then this will be very simple. You don't have to you will just get rid of this mode thing, and you will just write some straightforward algorithm that we are writing in this loop. So that is it about today, and I hope now you like this video. I know this is a very long video, but I have to just make you understand all these concepts. So that is it about today, and you will just get this solution in our DSA repository. I will just paste this, and thank you for watching.